Bro. There's free donuts in Northgate. We gotta go now.
Alright then, let's go. But how are we gonna get there?
I was thinking Aurora, because it's faster.
Nah. We gotta take I-5 because the freeway is a lot shorter. We gotta get the donuts right now. Damn, girl, chill.
This is an extremely common problem. What is the best route to take to get to your destination? But before we can dive into this problem, we gotta talk about reference frames, or frames of reference. A reference frame is a coordinate system that you choose. It's a desired coordinate system. It's important to set up a reference frame because we need to know where the origin is and which direction is positive and which direction is negative. In most problems, a reference frame is arbitrary, meaning it doesn't matter. You can take going to the right as positive, but you can also make it negative. It's whatever you choose. If you're, let's say, starting at Franklin High School and heading south to go to Oregon, it might make sense to make south going positive. In the end, it doesn't matter. It's whatever you choose your reference frame to be. When discussing which route to take, many people will make the argument that their route is best because it's the shortest one. This argument is talking about distance. Distance is just how far have you traveled. It does not matter about direction. So for instance, let's say you travel 7 meters to the right, and I travel 3 meters to the right, and then 4 meters to the left. We both traveled the same amount of distance. It does not matter that I switched directions. Distance does not matter about direction. In physics, we're going to use meters to measure distance. Now, distance is different from displacement. Displacement is how far away an object is from its original position. Once again, let's say that you move 7 meters to the right and I move 3 meters to the right and then 4 meters to the left. Our distances are the same, 7 meters. But our displacements are different. You are displaced 7 meters to the right and I am displaced 1 meter to the left. So once again, distance and displacement are not the same. Direction does matter with displacement where it doesn't matter with direction. Now, to confuse you some more, displacement is also measured using meters. But don't get confused. Distance and displacement are two different things. So if we're both starting at the same spot and we end at the same location, our displacements are the same. Even if one of us travels a farther distance, our displacements are the same. So to figure out who will get to the final location the fastest, we gotta talk about time. So time, there's not really a clear definition what time is. Physicists today don't really know what time is. We're still working on it. But for this class, we're gonna define time as the amount of seconds for an event to take. I know, that's a really crummy definition, but for this class, it'll have to do. We're gonna use seconds to measure time. So naturally, in this discussion, we're gonna be talking about how quickly it takes to go a certain amount of distance. If you and I are traveling the same amount of distance, but I take twice as long as you do, you are obviously traveling faster than me. This brings up what speed is. Speed is the amount of distance traveled divided by the amount of time it took, or distance over time. In a given trip, you might not travel at the same speed throughout the whole distance. This brings up the difference between instantaneous speed and average speed. Instantaneous speed is how fast you're traveling at that moment. It's like you're in a car and your speedometer says you're traveling 25 miles per hour and you press on the gas and you can watch your speed increase at that moment. Now this is different from average speed. Average speed is taking your whole distance that you traveled and divide it by the time it took for you to travel that distance. Now speed is distance over time. We know distance is measured in meters and time is measured in seconds. So speed is meters per second. But wait! What if you don't want to talk about distance and time, but instead want to talk about displacement and time? This is what velocity is. Velocity is displacement over time. So just like how average speed is total distance over total time, average velocity is total displacement over total time. Now, just to confuse you even more, velocity will also be measured in using meters per second. Now, I know this seems confusing, but speed and velocity are not the same thing. We're going to look at the difference between the two of them a little later on, but for now, speed is distance over time and velocity is displacement over time. You got it? So one of the biggest reasons why we know that physics works is because we can represent real physical principles using math. We've already looked at using mathematical equations to express speed and velocity, and now we're going to use another mathematical tool to help express these same things. We're going to use a graph. So let's look at a position versus time graph. This is where each position should line up with a specific time of when we were standing at that spot. So for instance, just to make it simple, let's say we were standing at the origin at 0 meters at time equals 0. Let's say that you were moving at a constant 2 meters per second. So what that means is that at time is equal to 1 second, you have moved 2 meters away from your original position. At time equals 2 seconds, you should be 4 meters away. At 3 seconds, you should be 6 meters away. Now, how do we find the relative velocity of this object? Well, we know that velocity is position divided by time. And we know that in a graph that the slope is rise over run. Or, more accurately, the change in y divided by the change in x. Well, our y axis is our position, so we're taking our change in position and we're dividing it by our change in time, which is our x-axis. This turns out that the slope of a position versus time graph is your velocity. That's pretty cool. Take one.
It's beautiful, man. It's beautiful. That's good. It's good.
Take two.
Batman.
Take three.
A lot shorter.
Take four.
Okay, alright.
Take five. Time.